value of the hyperparameter which we wanted to set. So just run it. After run it, we can see that for max depth equals to 1, we got the best results. So, this hyperparameter is got tuned for decision tree classifier for the given Algerian fire forest dataset. So in the next cell, we are running again training the model for the optimal value, which is 1. So this whole part will return the 1. Okay. So for max depth equals to 1, our model got trained. And here you can see that its accuracy score will be 94.59. Again, these are some metrics to get the accuracy, to predict the testing data, to get the confusion matrix, and also to get the whole classification report. Okay. In the next part, again we will use another famous classifier, which is the random forest classifier, to predict that whether there will be a fire appeared or not on the particular data set. So we will use the Algerian fire forest data set, and we will train the random forest. We will use the random forest classifier to classify it. So to use random forest classifier, again sklearn provides its class. We can import it and we can train it. So the method is same. Just you first you have to import the class, and then you have to create the object, then call the fit function on the for the training data set. So the our random forest classifier is trained on the training data set. Then again, to evaluate its performance, we can use the same metrics like accuracy and confusion matrix and classification report. So in the next example, we will see the SVM classifier. So to the process is same. First import the class. So SVS class is inside the sklearn's SVM module. Create the object of the SVC class, and then to train this SVM on for the given data set, call the fit function for the training data set and just run it. So the procedure is same, and this is by this you got the accuracy. So for the Algerian fire forest dataset, the accuracy of SVM is 91.89. So is there any doubt till now? Let me see on chat. Okay, I think there is no doubt. Okay. So let's see our next example. So in the next example, we will use a mobile dataset in which each feature contains the information or configuration of a particular mobile. For example, what those configuration, what is the battery power, whether Bluetooth is available or not, clock speed of the processor, dual SIM is available or not. These are the features, and this is the information contained for each mobile. And the last is the price range. So what is the range of the price? So, okay. So here we have to, our aim is to check that, uh, aim is to predict that whether predict the price range. So 0 means that it is very low cost, 1 means medium cost, 2 means high cost, and 3 means very high cost. So, in this mobile data set, there are total 2000 number of entries, means 2000 number of data points. Each data point contains the information of a one mobile handset, and here we our task is to predict the price range, whether it will be the costly or not. So again, in this first we are loading the data set. So you can see that the data set got loaded. So we can also get the statistical information of each column of the data frame. So this is the data frame. Inside this data frame, this is the first column, this is the second column. So along each column, what is the we can get the statistical information. For example, for battery power column, total number of entries is 2000. The mean along that column is this, standard deviation is this, first quantile, second quantile, third quantile value of it, it's this, and the maximum value is this. So we can do it using this describe function. So from data frame, call this describe function, so you will get the statistical information along each feature. We already saw this df.info function, which will shows about the number of entries, some values of each column, whether how many number of non-null values are available or not, and what are the data types. For example, the for battery power, there are total 2000 number of non-null entries, means there is no entry for which the battery power value of its battery power is null, and its data type is integer. If there was some null values, then you have to perform more data cleaning operation on it, like filling those null values. In this case, there is no null values are available, so there is no need to do that. uh, Again, we are assign encoding labels field by this, and then okay, so there are total four different number of classes here, 0, 1, 2, 3, which is already discussed. In the next part, again, the next part is to divide the data into the data part, divide the data set into the data part and into the labels part. So here in this case, X contains the data part, which is the only data values of the data along each features. So it doesn't contains the last column. So why? Because we dropped the last column. We already saw this drop function. The second, in the next part, we will use the y will contains the class labels, which is the last column. So to get the last column, we can call easily this access it's the last column by df of square bracket, inside it's the key value. So the y contains the label part. So our x contains the data part, means values, and y contains the class labels, means first data point belongs to class 1, second data point belongs to class 2, and so on. Okay, after dividing the data set into the data and class label, again the same procedure, perform the normalization. We are seeing the same thing, which is the min max, using the min max scalar, perform the normalization. So this x train scalar will contains now normalized value, and we will train our model on this normalized value. Uh, the next part is to first, before performing the training the model, first we have to split the data into the training part and the testing part. In the here again we are splitting the data set. Training data set contains 70% of the data, and testing data set contains 30% of the data. In this case, we will use the again singular vector machine to classify the data set, or to predict the price range of the mobile. So to do that, as I already discussed, first import the class svc from svm module of sklearn package. Then create the object of this svc class, and from svc, to train the model, on the training data set call fit function, in which the first parameter will be the training data, the second parameter will be the class labels of the training data. So by calling svc.fit, our model got trained on this particular, on the given data set. To evaluate the performance of the model, we are using the same matrix. So this is the accuracy score. Okay, svc predicted, the accuracy of svc for the given mobile data set will be 82.67. So when we see the, let's see again the documentation of this svc class. So here in the documentation, you can see that these are some parameters which is required, in which there is one parameter known as kernel, which is already discussed in the theory lectures, that different types of kernel. Though the most basic is the linear kernel. The second is the polynomial kernel with some degree. If you wanted to pass degree also, when we are using kernel poly, then we have to pass degree also. So we can pass its degree into this third variable. And also there is one another popular and kernel, which is the radial basis function, so which is the rbf. So if we wanted to train our svc on the basis of, suppose, polynomial kernel, so we have to pass kernel equals to poly and its degree. Let's say degree be 3. So in this case, our svc model will get fitted, in which the kernel will be the polynomial of degree 3 on the training data set, and we got the model got trained, and here we can see that the accuracy score. If we wanted to use simply linear kernel, so for it, just pass kernel equals to linear, then to train it, call fit function and just evaluate its performance. So here for the mobile data set, for kernel equals to linear, we got the best testing accuracy. uh, okay, and this is the classification report. So let's see, we have our support vector classifier, and support, and we wanted to perform classification using svm. Here you can see that there are some parameters. The first parameter, which is the parameters related to the training, the first parameter will be c, whose value, which is the regularization parameter. So its value by default is 1, but it can be 1, 2, 3, 4, 5 like this. And um, we don't know for what value of c for the given data set we got the best results. Again, for the kernel, there are plenty of options for the kernel, and we wanted to tune this kernel option also, that we wanted to check that for kernel equals to linear, what is the accuracy, for kernel equals to poly, what is the accuracy, and get the best optimal kernel function for which we got the best results. So to tune it, I already um explained you how to tune these hyperparameters of the particular model, which is using the this grid search cv. So using this grid search cross validation, we can tune it. So let's see how to tune the hyperparameters of svc, of svm, using the grid search cv. In the first parameter, we have to set the values of the hyperparameters. So in the svc, let's say we are considering these two parameters, value of c and value of kernel. So first parameter will be c, and let's say value of c ranges from 1 to 5. The second parameter, kernel, let's say we want these three kernel functions, and we wanted to know for which kernel we got the optimal results, optimum results. So let's say linear Pauline RBF. So these are the parameters which these two parameters we wanted to tune it for the model for the SVC with these particular different values. So the first is, since in this case we have to tune for SVC, so I am calling it SVC. Cross validation, I am keeping it as 5. This first parameter will be same. Let's change it as SVC. uh, X data set should be at x small x. So first pass the training data set as in the first parameter. In the second parameter, pass the labels and then fit it. So by this, after running it, we will get the fitted parameters. It will take some time. Okay, so after running it, we can see that for c equals to 5 and the value of kernel for linear kernel, we got the optimum results. So we can use these values to train our SVC for the given data set. So to train it, as I already explained, first create the object of SVC, then from the object call fit function for the trained data set. So our training data is into the xtrain variable and label is to the ytrain. And here in this case, while training, we will pass these values. So here we know that for c equals to 5 and for kernel as linear, we got the best results. So passing value of c as 5, kernel as linear, and just run it. So now our classifier got fitted on the training data set for the tuned hyperparameters. Now to evaluate it, first we have to predict it. So to predict it, from SVC call function predict, we want to predict for the testing data set. X test. Okay. So what it means that for the first data point of the testing data set means the first mobile belongs to the class 0, which is the very low cost. The second data point belongs to class 1, means that its price range will be medium low. The third point belongs to class 0, fourth point belongs to class 2, and so on. So by this, our model performs prediction for the given mobile data set and predicts that what should be the price range of the mobile on the basis of its configuration. So just I am assigning these predictions or predicted labels inside ypred variable. To perform the evaluation, we can use accuracy score. First parameter will be the actual labels, second parameter will be the predicted labels. So its accuracy is 0.945 for the tuned hyperparameters. And we can also print the classification report again for the same these two variables. So this is from my side. Is there any doubt? And okay, I am stop sharing my screen.
Thank you, Atif. for a
Very nice.
nice presentation and explanation also. So I think it will help the participants to do hands-on on different classification techniques for different data sets. It will help them. So thank you very much.
Thank you, ma'am.
Thank you, sir. It was a very nice session.
Thank you. Thank you. It is also a very good experience for me.
Thank you, Ati, once again. Okay.
Okay, okay.